Hello.
Hey, Joko.
All set?
Yeah, I hope so. Um, the I have the slides up.
I
Um,
just opened
I
it.
don't.
Yeah.
I realized I never like it's would be. I don't know exactly how to coordinate for you to say something. Are you okay if like after maybe after just going through the agenda? Um, did you if you
I
don't
don't have slide. I was thinking of saying one, two sentences, but I don't have to say anything if
okay.
it's awkward.
Um, I think it would be great if you could, but if you yeah, so but either way. Oh my God.
You have to give me cue when I would say something, and
Yeah. Okay.
if you know roughly, that'd be good because I also have a dog that sometimes misbehaves and she's sick. She's got UTI, so maybe I'll need to take her out and such. Just
So
like your idea.
maybe I can just hand over to you for a few extra welcoming mentions after the agenda. Sound
Okay.
good? Okay. All right. Oh,
Right
and hi,
after
David.
both
Thank you so
days.
much.
Hello,
Sorry.
Sorry.
good morning.
Good morning. Thank you so much for setting up all the recording and the Zoom link.
Yeah, you're welcome.
All looks good. And I'm the host. Can
You are now.
I? And there's Peter. Can I make Peter a co-host as well? Or could you make Peter a co-host as well, just in case?
Try it. Let's see what happens. It should work.
Okay. 'All right. So good morning and welcome. I think we actually have quite a few people signed up for the workshop, so or at least two registered. So let's wait a few minutes and see who we get coming in here. And let me make sure I have chat.
Lynn, are you able to make Peter a co-host or should I be doing it?
Oh, sorry. Could you do that? If that, yeah.
Sure.
Okay. 16 participants. I did hear that 50 people registered. So, Peter, yeah, can you help me keep an eye on the between Slack and Zoom for questions if people are asking questions there?
Sure.
Mm. Or anybody from the SCOC, that'd be great too. morning, everybody coming in. We're just waiting a few minutes to see if we pick up a few more participants here, and we'll get started in just a few moments. Okay. Well, we've kind of stalled out here at a constant number, so maybe we should get going. Anyway, everyone, welcome to the SCOC workshop. This is workshop number 6. Yep, good. Just checking we weren't all the SCOC members. Okay, great. Good morning. And so this workshop we're going to run today, tomorrow, and next Monday. Okay. I just want to make a quick reminder. This is the SCOC workshop number 6, our sort of annual update and review of the survey strategy. Members of the SCOC are listed here on this slide along with their beautiful photos. They include, you know what, I'm not going to go through all the names, but I am a non-voting member of the SCOC, and I'm here as your host today. Federico Bianco is the chair of the SCOC, and she's also online, but she had a personal emergency this week, and so she's just going to be observing, but she's going to be taking a step back for today. All right. And all of our lovely SCOCs members. And I just want to personally make a comment of appreciation for all of their hard work over the last many years as they're guiding us towards the survey strategy. So, slides, there we go. I just also a quick reminder of our code of conduct. This is just Ruben's standard code of conduct, and it's just in place for this workshop as well. Just basically be kind, and together we can help Ruben be the most awesome it can be. If you do have any issues, you can reach out to myself or Fed, or you could reach out to your science collaboration code of conduct, point of contact. All right, so what are we going to talk about today? Our agenda for today, basically we just starting with some opening remarks, all of this stuff, a refresher on the SCOC and how the SCOC process works, how our survey strategy design has evolved. Then we'll get to our current OpSim 5.3. This is the set of simulations we have now. This is what we're likely to be starting the survey with. And then a very brief, very high level overview of the metrics. We'll have some time for questions. Then we'll have a break. After the break, we have the SCOC will present some assessments by their science areas. So this is a little bit more in depth on metrics. And we'll have a little bit more discussion. And then tomorrow, I just want to make sure we understand. So tomorrow we will have a little bit more in-depth discussion on some various topics. So a detailed description of the survey plan. This is the baseline V5.3. So this is what we would be starting the LSST with, and we'll talk a little bit about uncertainties in our simulation and what that might mean in terms of what will happen. Where things we know already are probably not entirely correct. And you need to remember to have some margin of error when you're looking at the sims. Then we'll talk about target of opportunity observations in the template tier. So we have some sims like doing different options for the template tier. Also, we'll just talk about templates and their generation. So Eric Bellum will be available to give a brief overview of where we are now for templates. And then we'll also talk about rolling cadence options. And in particular, some of the aspects of uniformity. Leanne Guy can give us some comments on what that means in terms of data release. And then we'll talk about a new question about the survey strategy that's come up, which is a coordination with DESI. And so the survey strategy options there. And we'll have some time for general discussion. Then we have that break and we come back on Monday, and this is a time for the community, all of you, and the science collaborations to come back and give us some feedback. So there's some times listed here, but I believe these are somewhat flexible depending on need and availability of the different science collaborations. So we'll have to coordinate on that, and I think Fed was probably handling that, so we'll pick that up. All right, so that's an overview for our workshop. I'm going to come back to talk about the SCOC members and the SCOC process. But first, I'm going to hand it over to Željko just for a couple of welcoming words from the project.
Good morning, everyone. Let me extend Lynn's thanks to the SCOC, our committee that put a lot of work into cadence optimization. It's also great to see so many people on the telecon. It's great to see that people are interested in further optimization. We've been doing this for 20 years, so the community has provided input since day one, and that's how we got to where we are with baseline. So between last workshop and this one, a significant milestone happened that I'm sure you all know about. We finished the observatory, and now we are operational. And what that means is that we don't do only simulations anymore. Now we have the actual observatory. And that has impact on simulations because now we understand better what we can deliver, and we can now simulate with greater fidelity how we will be getting data. Of course, we need to remember that in an absolute sense, we can't promise anything at the level of 1%. We have weather, we are ground-based observatory, and roughly speaking, the impact of weather on uncertainties of our predictions are of the order maybe even 10%. So what we can do with better fidelity is relative assessments between cadences, but nobody can promise to you today how many visits you will have 10 years from now with an absolute accuracy better than 10%. So we can only do relative comparisons, and you will learn that once we implemented a little bit more downtime into simulations, and we allowed for the speed of observing that we are achieving now, we think it will go up, but what we have now, Lynn and her team predicted we would get in 10 years about 90% of visits. So it sounds like big impact, but again, in terms of absolute numbers, weather itself is a 10% effect. So we should compare in a relative sense first until we can get to the level of few percent later in the survey. So thank you again for helping us. I know you represent the whole community, all our 3,000 plus members of science collaborations, and this collective wisdom and collective knowledge is one of the main reasons why we have this cadence that withstood the test of time for many decades and has been optimized many times, but we still kind of have the original concept in mind when we do further optimization. So we are now talking about details that we didn't talk about a decade ago. So that's exciting to see that we are getting to the end point of optimization with simulations, and we are now beginning LSST very soon. A recommendation was issued by the start of LSST board to to Observatory Director Bob Blum to start LSST, hopefully by the end of June. Now it needs to go through the management board of Rubin Observatory, then needs to be approved by ORA, SLAC, and funding agencies. We hope to get it done within the month of June. So very soon we'll declare that we are starting LSST. In practice, what that means is that priority at the summit is changed from engineering observations to scheduler-driven observations. We will still allow for a little bit of engineering on-sky observing, and you will get all this detail in due time, in few weeks, once we hopefully go through the approval process. All the documents that we collected for the management board, all the relevant technical information will be shared by everyone, of course. At this moment, we are still waiting on the management board. But that's the news from the summit, that we could very soon change the priority from engineering to the actual feature-based, scheduler-driven observations. So thanks, Lynn. Back to you.
Thanks, Shelko. Actually, that was great, and you pumped us right up with that announcement about that we could start within this month. So excellent. All right, like I said, I was going to give an overview of the SCOC process and how they were making decisions. Again, we have our SCOC members, who we appreciate very much. They do a lot of hard work. Guiding us towards the gathering input from everybody and getting us towards the best survey strategy options. I wanted to take just a moment to reflect on all of the work we've all done together to get to the point we are now. So at the moment, we have this survey strategy we're about to be ready to deploy on the summit. But over 10 years ago, we did not. No, we had a strategy which was designed by the construction project. It was not completely optimized. Certainly, we didn't have all of the community input that we got since then. So over the period of the last 10 years, we've gone through building this process of creating OpSims simulations and releasing them to the community, analyzing them with metrics. We had the big science collaborations metric analysis book that and then we had a whole series of community white papers. We've had community cadence notes since then, and other the more minor white papers. That first one was a really big call. The SCOC was only instituted in 2019, but that you can see that these members have been serving with changes. There are terms on the SCOC since that point. And over the process of going through this cycle of creating simulations, releasing them to the community, understanding what the community's feedback is for those simulations, and then updating the strategy and result, we've run through over 1,000 simulations that between the project and the community that we've all looked at and analyzed together. And as a result, our survey strategy itself has evolved. The big significant thing, of course, was the change in the footprint that happened around 2021. And since then, the survey has kept evolving and tweaking in the smaller details, of course. So this is us optimizing the survey strategy. But yes, it is truly the work of hundreds of people in the community helping us make sure that the LSST is as amazing as it can be. Oh, I didn't realize this was a two-part slide. And as we stand here at the edge of deploying a survey strategy configuration and scheduler configuration on the summit, it's worth reminding the whole process was set up so that we could work together instead of against each other, because it is true that in a war, everybody loses. So some people could lose everything. Every individual loses something, and together we lose our togetherness. I think I think I think Phil said it well when he came up with the term cadence diplomacy to talk about the process of working together to make a survey strategy that worked for everybody. Just a little details about how the SCOC works in practice. So the SCOC have a charge. The charge was actually listed on a slide a few back, sorry. The process is that they gather and review community feedback and updates from both the Rubin operations staff and from the community. These could be white papers, survey simulations, metrics, code for new metrics, and progress reports. And then the SCOC writes recommendations, which are delivered to the Rubin operations director. So we have this series of phase 1, that's PSTN 053, phase 2, phase 3, recommendations, and there was also the AppJ focus issue, which wasn't exactly a recommendation, but I thought was a very nice way to both document and acknowledge the community's work for survey evaluation. And shortly there will be a PSTN 057, which will contain the recommendations at this stage as we go to deploying a strategy on the sky. The SCOC is a standing committee during operations. They don't disband. There are terms and new members are appointed, but the committee itself will continue through operations. This reflects the fact that there are still many survey strategy decisions to come. First, we have to respond to changes in the observatory performance and changes in the scientific landscape. So these might be more major decisions. But then also there are things like if we do have enough time to implement more microsurveys, the SCOC could determine what those microsurveys would be, things like this. All right, so now let's move on to the actual survey strategy simulations, the 5.3 simulations. So these were announced on community on May 26th. And these are exciting for me because these are the culmination of a lot of work, and they are what we are going to be, what we're planning to be deploying to the summit when we're starting the survey. So the baseline V5.3, this is a very short cycle of releasing the simulation and asking for feedback. And we acknowledge that. It's a little unfortunate. There were a lot of things that were evolving, though, in terms of what our understanding of what was going on with the observatory, what our expectations were, what the needs were in terms of some of the aspects of what we needed for the images in order to be able to successfully create templates and so on. But in essence, this really is primarily an update to our previous baseline 5.0, which we released, I think that was last year. So the updates are responding to what we learned about data management needs This is coming from what we saw happening during the SV survey and early commissioning, and what we've learned about some operations from the early operations and updated future engineering schedules. So it is a very short cycle. A lot of this is actually a smaller change than we've had in previous years. All right, so a reminder about our general LSST survey strategy. The strategy in general is documented at this website that's on the left here, survey-strategy.lsst.io. And a lot of these plots still say 5.0. They're not substantially different with 5.3, but I am working on updating the website. So we have the wide, fast, deep. The wide, fast, deep still is the bulk of the survey visits. It actually gets about 80% of survey visits. This consists of both low dust and higher dust extinction regions, so like the galactic plane wide, fast, deep region and the low dust wide, fast, deep region. The visits are acquired primarily in pairs and primarily in 2 different band passes so that we get colors within the same night for each observation. And after year 1, rolling cadence begins over this footprint. So we split the sky into alternating declination bands. And in 1 year, you can see this on the right in the lower section. In 1 season, we'll emphasize one of these bands, and in the second season, we'll emphasize the other bands. So you get a higher and lower cadence, a higher and lower number of visits, depending on whether you're in an active or less active season. And this manages to bring the cadence, to improve the cadence, to bring it to a shorter inter-night visit gap during the times when you're in a high active phase of the rolling cadence. When we do get around to talking more about the rolling cadence, it's worth thinking about this as you have pairs. So at every point in the sky, if you have a high active season, you're going to have a low activity season. So you have these come in pairs of seasons, and season being a year at any point in the sky, but like how long the exact time period for that year depends on where you are in the sky. All right. Next, we have mini surveys. This is just the next category of sky coverage. So we have the North Ecliptic Spur, the Dusty Plain, the South Celestial Pole. And these are marked in the plot there on the left. And each mini survey has a different filter balance. They can have unique filter balances. And the mini surveys in the Wide Fast Deep, and they also have different numbers of goal ratios of visits. And they're balanced in terms of the overall ratios of visits, so not the specific numbers of visits. So even if in a particular simulation, the Dusty Plain got 200 visits and the Wide Fast Deep got 800 visits, if we had, let's say, 10% less time, they both would decrease by 10%. And the deep drilling fields are sort of a next category. So we have 5 independent deep drilling fields. They're listed here on the left. There are 6 central pointings because the EDFS field is split into 2 to cover a wider area. Each of these are defined with observed with a predefined sequence of visits with a predefined goal cadence. But if they miss visits, they will try to make it up for a certain period of time, and then after that, it'll drop. So these are observed in a slightly different manner than the Wide Fast Deep because they have this goal cadence that is enforced a little bit more strongly. Something that was introduced at V5.0 that is certainly different than we had previous to 5.0, but was a part of the 5.0 simulations, is that the DDFs are observed with what we call an ocean cadence. It's kind of like rolling, but very extreme and tied to the deep drilling fields only. So each deep drilling field has one deep season that has very long sequences during that season. So they have 100 or more visits in a night during the deep season. And over 50% of each deep drilling field's visits are acquired during that deep season. And then the other years are what we call shallow seasons, and they have much shorter sequences where it's just a handful of visits for every time they come to that field during in the cadence. And so the shallow sequences are more aimed at monitoring and getting frequent, slightly deeper than YFS deep, but not significant, not hugely deeper. And then the deep season is aimed at getting very much deeper, very high redshift objects with also a fast cadence. I believe, yes, so that's our ocean cadence. And on the left, on the bottom, you can see a plot of the cumulative visit acquisition for one of the fields. So this is XMM LSS. And so you can see that over the little peaks are the shallow seasons when it's observed, and then that really big one is the deep season. So you can see most of the visits come in during the deep season, and then in the other seasons we still acquire visits, but it's not nearly as overwhelming. Then we have the last category are microsurveys. So these are small programs that require much less than or about 1% of survey time to execute. So the SCOC currently approved and has approved since I think around V4.0, near sun twilight microsurvey. And this starts running at year 1 and continues running throughout the survey. So this near sun twilight survey runs with 15-second exposures instead of our standard survey exposures of 30 seconds. And they're high air mass visits towards the sun obtained in quads in the same short period in RIZ. And this executes, it really does execute during twilight. It's from minus 12 degree twilight to just after minus 18 degree twilight. For our normal observing, we do start and end observing at minus 12 degree twilight. So we're still using twilight even on the nights we don't run the near sun twilight survey, which only runs every few nights. And then last is our, but not forgotten, is our targeted opportunity program. So up to 3% of the survey time can be directed towards TOO follow-up. The general plans for TOO follow-up are described in the proceedings from the Rubin 2024 workshop. And there is a TOO advisory board it stood up, has members as a charge. They provide guidance regarding specific TOO events. And we were able to execute this, or to practice executing this process during commissioning. And so this advisory board has some practice with actual observations as well. All right. I'm going to pause really briefly if there's questions. So before we get into our V5.3 simulations and what the changes are, if there are any questions on the basic survey strategy, could you guys go ahead and either type them into Zoom or raise your hand? Oh, right. Sorry, you were right. Cadence diplomacy was Canute as well as Bell, yes. I like that. Did like that white paper. David.
I was just wondering if you've tried to break the sims in that if you take the data and make it like 20% worse or 20% better, what actually gives?
Yeah, we haven't done quite that extreme, but as we'll see today, we have actually very recently reduced our time on the sky by about 10%. Yeah, we do run sims with a variety of weather. It's not as extreme as that, but like our suite of observing simulations does include ones where we use different time intervals of weather, which is basically our weather comes from cloud coverage records from CTIO. I'm pretty sure it's CTIO. And if the cloud coverage record, these are these old 0 to 8s, right? The 1/8 of the sky coverage. And if the coverage exceeds, I think we have set the threshold at 3, essentially, or 0.3, sorry, after you convert it to a decimal, then we close the telescope. And so this gives us a weather closure rate that matches the overall weather rate. So it's worse in the long nights of southern winter, and it's a little bit worse in some parts of the southern summer. So we get this weather record that matches the historical database, but we can also offset into different years of that historical database so that we get sort of some variation in both the seeing and the closure times of the observatory. And so we do that, but we don't do it as extreme as, and now we took out 20% of the observing time. I also don't know if we should really add 20%, but yeah, it's
Things can happen. There are cases where you get ahead, and it's a good problem to have. But
yeah.
but I guess if
I think
ask
that's
just
not a terrible idea. We just haven't gone to quite that extreme.
yeah. In general, sorry to just keep talking, but that uh, wide, fast, deep versus mini surveys that does one suffer more than the other or gain more than the other?
No, those would stay. Those just are natively balanced inside the scheduler because of the fact that their target maps are ratios, so they will rise and fall together. The things that don't change as much are the deep drilling fields and the micro surveys, the very, very small surveys. So,
Okay, thank you.
all right. So baseline V5.3, I think this is the thing that everybody is probably most curious about. So the changes in the strategy itself are in response to what we learned about data management and how data management needs to use the observations that we acquire with the survey. Most of the issues we found involved chip gaps and coverage on the sky. So we found for the DDFs, when we were observing for the SV survey, and anytime this will be true at any point while still building up the background sky coverage, but it also is likely to be true when we have those very, very deep sequences on the sky. The DDFs need dithering both within and between nights. So previously we had no dithering within the night for efficiency so that we didn't have to settle between visits. But that was very bad for the coadded images or the chip gaps aligned, and we didn't have enough coverage to fill those chip gaps. And I think no matter what we do, this will still be bad. And it's not just chip gaps. That's sort of the major thing that jumps out, but also scattered light. This is slightly less of an issue now than it was when we were running the SV survey because additional baffles have been put in place for blocking stray light. But stray light is an issue with the large field of view of the telescope, and so dithering is important so that you move those stray light features off of the very low surface brightness objects you're trying to see and measure. So this is a small hit for the efficiency for the deep drilling fields, but this is one that it looks like we just really do need to do. This was one of the areas we had marked as is this something we need to look further into. Yes, Eric.
Hi, Lynn. Thanks for explaining this. How big are the dithers and how big is the efficiency hit that results?
Yeah, so the efficiency hit that results is okay, I can tell you what it is for the simulations, and then I can say that in reality, in what we're seeing from the summit, the visit gaps do have some scatter. So in the simulations, it becomes just yet another slew. most of our slews are very small. Our slews have a movement and then a settle, right? And the settle is most of the time. So basically this, by having to dither at all, we have to settle. And so these look like slews between most of the fields. They might be slightly shorter, just because of the fact that the movement is even smaller. But in general, this makes the dithers, they tend to look just like regular slews. In practice, our slews, our visit gaps, I'm going to say visit gaps because slews carry this very specific meaning for the people at the summit, where this is the time that the TMA is moving. So the visit gaps do show some scatter, and some of that, and they have extra overhead beyond what we think. And I'm going to talk a little bit more about that in a minute. But a lot of that, I think that will settle down. But this is one of our little bit unknowns. And then back to the deep drilling fields. So only Cosmos has a deep season within year one. Cosmos has this deep season very early because of the fact that it is serving as a pathfinder for final co-added depth for the deep drilling fields and for like everything else. So Cosmos gets a lot of observations early on so that we can understand what's going to happen with the deep drilling fields and other parts of this as we go through the rest of the survey. In some versions of the simulations, we had also added, I think, an EDFS deep season in year one, but we have taken that back out as decided that was a bad idea and we should put that off. All right. The other thing we learned is that template creation was more difficult than the very preliminary requirements that we had known about previously. So we learned that the technical requirement was 95% pixel coverage of a patch, which is detector side. Now, this one is tricky because the scheduler, the FBS, and MAF, our metrics analysis framework, work in things that are the size of the visit. And the scheduler works in a circular visit footprint, and MAF works in the camera footprint viewpoint. But the data management pipelines all work in tracks and patches, which are very specific locations and sizes and quantities on the sky. And so when we say, oh, we think we have enough visits at this point, we might be talking about the circular field of view. We might be talking about visits we think hit silicon, but they might be talking about visits that hit, that went into a detector in a single image, and then there was no edge in this part of the detector. And so the fact that we found that in order to really make templates, which are a form of coads, that they needed many more input images than we thought that they needed, is partly that there was a little lack of communication, I think, about like what the needs might be, but also a lot of it is coming out of this chip gaps and the coverage and the fact that we're counting slightly different things than they were counting. So we think we have this translation in hand, that what this actually means is that we need somewhere between 5 and 6 visits from the scheduler's point of view that overlap a given point. And that might get them to the minimum coverage from data management point of view. So previously we were aiming for 3, but we actually needed to be aiming for many more than that. The other aspect that was a little bit difficult is that the requirements for image quality, and this is both full width half max and the transparency, mean that because these are set slightly differently, it's harder to set them retrospectively when you're trying to make incremental templates and templates that you're going to put in place for the survey for a long time. So if you have to aim for a particular threshold in full width half max and transparency, that you don't know when you're starting, but you know you are going to make your co-ed with that, then when the weather is good, from our point of view, it should be a priority to acquire those images, because otherwise you risk not getting enough images under those conditions. And when we evaluated templates from the point of view of like our metrics previously, we were doing something a little bit more like, okay, we have a certain number of visits. Do they meet a minimum threshold that we had essentially set in retrospect, knowing what the outputs would be? And we also said, and you know what, maybe you can also just make something that meets them, like use your median number of images you have so far. So between these two things, needing to acquire more images in the template for the purposes of template building, and knowing that you need a lot of those to meet basically the median requirements over the sky over time, implies that when the weather is good, the atmospheric seeing is good. It should be a priority to acquire those images. And to support doing that and making sure we get that minimum number of images over the whole sky, we added a separate template tier set of surveys. So this is a new thing that we put in v5.3 that supports what we see that the pipelines need as inputs to make templates. So these templates are programmed in pairs. This is kind of new. When we first put in the template tier in our 5.1, which was not a series of simulations we publicly released, they were available, but they were more like works in progress. We put the templates in as single visits. Now the templates are programmed in pairs. This saves a lot of solar system science, transient and variable science that need those images in pairs, even if they can't necessarily use those images when they're acquired. You can use them at data release. And I will note this is important because in the first year, which is the only time that we have this template tier running in the simulation, those templates take up like 70% of the total visits. So we acquire them in pairs. They're mostly different filters. Some of them are the same filter. So like U is paired with U, because we needed to do that to pack it into the dark time well enough. So this is a change in the survey strategy as well. Okay, now the big thing. This started the big thing. So when we look at the observatory performance and the observatory downtime, we also needed to make changes. So up until 5.0, the Simone performance was modeled as the TMA, the telescope mount assembly, is moving at 70% of its max speed with a 3-second settled pursuit. At v5.0, we moved from the 2 snaps per visit, 15 seconds and 15 seconds for a 30-second visit, into a single snap visit. And we knew that there might be some problems with the TMA, and so we moved some of that 70% max speed, we moved that down to 40%. This also meant that we were basically holding some of the increase in performance from the single snaps as contingency. It's not contingency. 40% max TMA movement was more realistic. However, it is still not representing our current TMA performance, and 40% may not be super realistic either. So our current summit performance is something like 20% max speed TMA movement with a variable, but never less than 3-second overhead. So and I say overhead here because it's not exactly settle. When we said settle, we meant after the TMA moved, we sat still at the same spot on the sky while the telescope settled and reduced any ringing or vibrations. But this is overhead, and so some of it is coming before the TMA movement, some of it's coming after. In some nights, this overhead has been higher. It's It has been close to 3 seconds for fairly long periods of time, and recently it's varied a little bit more. So this is one of the things I think that we don't necessarily know super well yet, and also I think it's going to improve. One thing that we may actually be able to do in theory is instead of a 3-second settle, a 1-second settle, maybe 1.5-second settle for each of these slews. And that's based on some things we know about where those overheads are coming from. And it's just that, so these are known avenues for improvement. The exact solutions still need to be tested and worked through. So it's possible that we will end up with a 20% TMA movement with a 1 or 1.5-second settle. What we put into the simulations was this 3-second settle and a 20% TMA movement. It's optimistic at the start of the survey. It's probably pessimistic later, and I don't know when it changes. Saurabh?
Yeah, so just can you remind us what is the read time that we're using right now, and if that's expected to change?
So the read time is 3 seconds, 3.07 seconds, and that is not expected to change as far as I know.
So, for example, like with the DDFs, with a small slew, a very small movement on this guy, and let's say 1.5 second settle, it seems maybe feasible that that can all be done within the 3-second read time or very close to it, so it wouldn't actually be an efficiency loss.
Yeah, I think that's true. And from the Summit's point of view, they moved from a 2.4-second readout to a 3-second readout under the assumption it would be hidden in the slew. But I think that, yes, if we get a very quick settle and low overhead, and we have these short slews, they're going to be pretty close. So I think you're right. That's one way, another way to look at it. And then this is the big one. So we also have a lot of updates in the on-sky availability. And this is, so I have 2 columns here. On the very far right is what we had in v5.0. And this is also what we had in earlier simulations, but I'm just picked v5.0 as the reference point. And then on the left is what we have in our new simulations, v5.3. And these are more realistic. I can't say they're exactly right, but I think they're much more realistic. So let's talk about these a little bit. We have planned maintenance. So these are things like every year we have to go in and do maintenance on the telescope, on the observatory. In v5.0 and in all previous simulations, this was at 2 weeks per year. In our new simulations, we consulted with the Summit again. Those 2 weeks per year were pretty outdated. We now see that they want that they need 3 weeks per year, and in years 4 and 8 weeks per year for an extra 8 weeks per year for additional maintenance. The 8 weeks per year is the part where I think there may be some uncertainty around still. The 3 weeks per year, I think, I do not think they're going to go below 3 weeks per year. Okay, planned engineering time. So this is like for engineering tests and also for things like ongoing calibrations. So in v5.0, we had none. Nobody ever used the telescope for calibrations at night. However, that was not very realistic. So in v5.3, first of all, we have 1 night every 25 days for the whole length of the survey. So this is like ongoing calibrations that need a very dark dome, basically. You can think of this. It could also be some other work that has to happen at night, but the primary thing there is thinking, okay, we really need to make sure we get calibrations. There is also some additional test development time. So this is put into v5.3 at 2 half nights per week for the first 6 months. This is a little bit uncertain, so we'll look at how that might be different, but this is sort of the placeholder we put in here for v5.3. So those are like the things we expect. Then we have unplanned downtime. So unplanned downtime are faults or problems with systems that come up under the course of operations. In v5.0, we had a more downtime in year one. So we actually started out with like more faults happening at the telescope. We started at like 25% of the time was lost due to faults or other short interruptions. And then it ramped down to 3% very quickly at the end of the first year. We also had based on an old model, which had like multi-night periods of downtime. So things like, and these range from one night where it might be, we lost a lot of camera systems, basically, but we could recover them very quickly, to several nights, like, we have to fix something about one of the mechanical pieces in the telescope. And those in 5.0, we only had those from the end of the first year onwards to the end of the survey. What we see when we look at what's happening at the telescope is that those multi-night downtime periods needed to occur over the whole 10 years. So we put those back to the whole 10 years. So this gave us about 2 weeks of extra downtime. The other thing was that we're actually doing better than we had at the start of the v5.0 simulation. So we don't really need to take out 25% of the time. We do probably need to take out 20% of the time. And then the ramp, instead of going from 25 to 3% in a year, seeing like how this is changing or changing very slowly, we changed this to go from 20% down to 5%, but over 3 years. So we have more downtime, but like a little bit less concentrated right at the start of the survey. In all of these simulations, we also have weather downtime. This is based on those cloud cover records that I was mentioning earlier. The bad weather in our simulation can cover the downtime. So if we have a cloud cover night on a night that was supposed to be like an engineering time, the cloud cover just takes priority. The engineering time doesn't get rescheduled. So that's just how this works in our simulation. All right, and we're coming up to 9. So I think we're going to go just a few minutes over here. Okay, the things we have not included in any of the v5.3 simulations. We don't say we lose visits due to poor image quality. So if the AOS pipelines or AOS control, for example, does not quite work, we're not counting that because we can't model that. This is not a high fraction of images are lost to poor image quality from this reason right now. It has been a little bit higher in the past, but this is on the order of 1% or 2%, I think, at the moment. So this is, and it should improve even further. So this is not a major aspect. We don't include the additional degradation of image quality due to increased system contribution that we're seeing from the summit now. What we did in v5.3 is just use the same atmospheric seeing contribution and same system and wavelength models as in our previous simulations. So this lets you compare the seeing with our previous seeing, but it doesn't fold in the fact that we have a slightly increased system contribution at the moment. Partly this is because I don't know how to model how the system contribution will improve over time. So I just didn't. We don't model depth loss due to cloud extinction. So we use the clouds to close the telescope, but we don't use the clouds to knock out some of the photons. Hopefully we'll be able to add this in future simulations, but we don't do this at present. And we also didn't include the fact that our throughput now at the summit is probably about 10% better than what we have in our simulations. So the thing that's a little bit tricky here is the simulations do include they're a little bit lower because they include an average throughput loss over time. So we just, for all of the simulations, instead of modeling how that throughput falls over time, we just always said, this is the average throughput for all years. I still don't know how this is going to fall over time. It does look like the throughput has been about 10% high and is still 10% high compared to from when we started. So this actually could mean that we overall have a slightly higher throughput for the observatory throughout the lifetime of the survey. But this, I think, is also a little bit too early to really tell. So Joko dropped this earlier, but maybe you all knew it anyway. The net effect of all of these changes in downtime of faults and slew performance and so on is that we have 10% fewer visits than we did with our v5.0 simulation and downtime. So instead of 20 million visits total, we have now 18.5 on average. The primary effect of the survey strategy changes is in year 1, because that's when the template tier is running. And then after year 1, the template tier turns off. So the effect of the template tier is that we have more even coverage over the sky, because the templates, you need the same number of visits no matter where you are. So WiFS Deep or microsurvey region, for many of the bands, it just pushes us to this minimum number of visits. And the other thing is our U and G band visits in year 1 are slightly higher than they would be otherwise in v5.0. And that's because the threshold we need for the templates is higher than we would have naturally got with our distribution of visits between bands. So this makes us a little bit bluer of a survey, especially in year 1, just slightly. And then it also makes the coverage, especially in the bluer bands, more even in year 1. Now, like I said, the simulations were posted on Community. There are a description of the various simulations that are in there. It's not been updated for all of these, so I need to go back and add a few more simulations, but it does have the simulations we have so far. So we have the baseline, which we talked about. We have a comparison survey. So comp survey v5.3 is interesting because what it does is it uses the old observatory performance with our new survey strategy. So you can use this to compare to previous baselines to see what is the effect of the change in survey strategy. Then we have a potential variation that could affect year 1. So faster template is one where instead of doing the templates in the standard visit time, so instead of 30 seconds, we said, what happens if we make these template visits only 20 seconds long in GRIZY? And because U was always 38 seconds, this now goes down to 25 seconds. The point here being, these visits are supposed to be happening in the best conditions. So they have deeper limiting magnitudes anyway. So, and the thing we're looking for templates is epochs and depth. But like I said, these are deeper visits anyway. So by making them a little bit shorter, you can still have a reasonable depth, but you get more epochs in the same amount of time. However, there are some aspects to consider about this. So we have an RFC, request for comment, pending for this within the project. There may be some practical drawbacks that we can't use this. But otherwise, this is something to consider, and it would affect the observations in year 1. We have 2 simulations that evaluate the impact of not starting rolling cadence in year 2. The idea here being, if we don't have templates yet, we should maybe not start rolling. So let's push rolling off into at the end of year 2. And so there's 2 of these simulations. The difference is, remember I said that for the rolling cadence, there's this, you have pairs, right? You have a high cadence year and you have a low cadence year, and they always come together. Actually, they're in triplets, essentially, because there's also, we inject uniform, like medium average cadence seasons, so that we get a more uniform data release. So what these 2 simulations do is they delay rolling until the start of year 3, and the 2 of them do make that uniform data release year at different points in time. So roll mash has that second. Normally with the rolling starting in year 2, it would be, we'd have uniform data releases at year 1, 4, 7, and 10. With roll mash, it's 1, 2, 7, and 10. And with roll up 5, it's 1, 2, 5, and 10. Okay, and then the something we'll discuss more tomorrow. We also have 2 simulations that advance observations north of about minus 20 degrees, very roughly. And this is to support the DESI 2 targeting. And so what this does is it pushes observations in the first 4 years of the survey to meet the thresholds that are needed for DESI targeting. Primarily, this impacts UNG, but it does impact to a lesser extent the other band passes. So we have 2 different simulations where we vary how we're doing that. And the last, yes, I just have a few more slides here. I'm running into my question time a little bit, sorry. So we have the metrics analysis framework. If you aren't familiar with math, there's a little bit of documentation at this website, ruben-sim.lsst.io. We also have a bunch of tutorials online. The upshot is math is our framework for evaluating the surveys, and it gives us something that we can run metrics. We've talked to the community about this. This is our way of communicating about within the framework that we can then run independently about how the survey is performing. At the link here, there's sort of a high-level summary of the current metrics run against these simulations, and also their comparison to the metric values in previous years. Ooh, what did I do? Oh, yes. Okay, so this is our overview of what the impact is using math. And these are also in that notebook that I linked on the previous page. So fewer visits, 10% fewer visits. On the right, you see the number of visits for the different simulations that we've run, including all the way back to v4.0. The bars here, what you see, that's the uncertainty that we have coming out of varying the weather coverage. So it's not really the full uncertainty. You could have additional uncertainty coming from the downtime of the telescope itself, maintenance, or all of these other things we've been talking about. But if you just look at the impact from weather, we think that that's about equivalent to the height of that bar. Of course, this is only within the bounds of our records, and things could exceed that even, but this is our estimate. So you can see, yeah, there's some uncertainty on this. There's probably more uncertainty on this. And also we lost 10% of our visits. That also affects the area coverage. So on the left is a plot of the number of visits and the area that gets covered to that number of visits. And so what you see here is that the purple line is our old baseline 5.0. As we go to 5.3, that's the orange line, and it just has a noticeable impact. This is pretty understandable if you look at this and you say, okay, that the big flat line, you know, the slope, flat area in the slope from about 200 to 600 numbers of visits, that's the wide, fast, deep. The little plateau at the very left of the plot is the mini surveys, and then things fall off and you have like the deep drilling fields on the right, basically. But this is how this falls off tells you a little bit about the uniformity of the coverage and how well we're covering out to the edges of the footprint, but also where it drops just tells you where we ran out of visits, basically. Now, I will say the co-additive depth is affected by the survey strategy change. However, it's affected less than the number of visits. So the number of visits just fell by 10%. The co-additive depth actually falls only by about 5%, depending on the band. G-band actually did better because of the fact that we had to put more visits into G-band early in the survey, and those visits that we put into G-band early in the survey in the template tier were very good visits. So G actually gained a little bit of depth while the other bands lost. And so you see this when you look at the high level metrics. So this is our grid, which you may have seen before. It's showing you the metrics, high level metrics, the summary metrics, grouped by different areas. So on the bottom on the left, and you can see that we have some of these SRD metrics, like the number of visits per point in the Y-fast deep, the proper motion error, the parallax error, and these go up. And so some metrics and types of metrics are more affected than others. If the metric really scales with the number of epochs, and doesn't mind so much about when those visits are, then it will fall by about 10%. Metrics which depended primarily on the coadded depth are less affected. So you can see, like, for example, the number of galaxies and how you can read this. Sorry. If you look at baseline 5.3.1, everything is normalized to this. So if you have the same color in your metric and they're normalized across, like, so the NEOs, for example, don't change very much left of V5.3 to the right. They were less affected for the bright objects. The faint objects, you can see they were more affected because they were more blue before we added the extra downtime in baseline 5.3. So you can see that some metrics were less affected, like the number of galaxies, which primarily depends on the coadded depth, but does depend on the filter balance a little bit. Sorry, it's an I-band, so that's not, it's making, but you can see that it fell a little bit, but not as much as some of the metrics, which just depend on number of visits. And metrics which needed a subset of the total epochs are less affected. So this is why the NEOs and the TNOs don't fall as much, because the discovery is using a subset of all of the visits, but what can happen with these is that the achievement of their goal could be delayed. And because I'm in this grid, we're only looking at the performance after 10 years. This is just not showing up here. So so there's some metrics which aren't strongly affected. Metrics which depend on a fast cadence in all years, and in particular need color information from those visits, those had the biggest effect. So those fell by more than 10%. And you can see this in this big glump of dark blue here. So before we added the extra downtime, these metrics were much better than they are after we added the extra downtime. And it's not entirely clear why this falls so much, why it falls more than 10%, but it probably has to do with some details of the visit sequencing and how we're getting those visits. And it may also be influenced by the templates in the first year. So those kind of metrics really are showing a larger hit. Okay, so that's our high level metrics. And after the break, we'll hear more detailed metric analysis from specific areas from members of the SCOC. And I just put a couple plots in here to fill out this slide, but these are some ones that I think illustrate that same thing. So on the left is the SRD metrics. This is a relative plot as the metric values are normalized to V5.3, like in that previous one, but instead of having a color, now they have a line. So you can see this black line is the number of visits per point in basically the Y-fast deep, and you can see that falls by about, actually even a little bit slightly more than 10%, with 5.3.1. And then this is like the total number of stars. So you can see this doesn't, and oh, that should have a band listed, doesn't it? But I think that's, oh, I picked our band. So this falls a bit, but not as much as it might have. And this is the characterization for potentially hazardous asteroids. So this also falls because it depends on the cadence and the timing of the visits. But this one is not as much because it doesn't depend on all of the visits, just in some years. Okay, So, and tomorrow, as a reminder, we'll talk about the details of these various simulations and the variants on them. So basically, we'll zoom into that area within the 5.3 simulations, not looking at the overall impact of 5.3, but what happens from here forward. All right, that's all of my slides for now. We have a break coming up at 9:30. So we have some time for questions. Yes, sorry, Mindy. Bindu, do you have a question?
Yeah, hi, thank you, Lynn. This is great. So one thing I wanted to understand, and maybe you said this and I missed it. Are there a fixed number of nights assigned for bad weather where the observatory will not be taking data?
No, it's not exactly a fixed number of nights for bad weather. The cloud, so we use the cloud coverage records to say whether the telescope is open and taking data or not. And then we set the threshold on those cloud coverage records so that it matched the approximate amount of downtime that we could see happening at, I believe it was Gemini, or we tried to match it so that the threshold that we chose matched the typical downtime at nearby observatories.
I see.
Now,
Thanks.
obviously, yeah, that's a moving target. So like this is.
No, I was just like curious, and I just wanted to see. I know in near future, I believe there will be a call for new micro surveys, but I was wondering if for some reason there is a certain night that became available, and there is an opportunity to pitch in a one night micro survey for a certain kind of science that require maybe a night long continuous observations.
So the SCOC will be holding a call for micro surveys. I think a single night survey like that is definitely in the realm of micro survey. We don't have anything that's like we have had a fixed night taken out of the survey. So
Okay, thanks. I'll look watch out for the call.
okay. Dan.
Sorry, for the ocean DDF strategy, is there a name for the high cadence periods? Just
So we were calling them deep seasons.
Or actually ultra deep seasons. Those are the ultra deep ones.
Okay, I was gonna say, but I've also seen the ultra deep terminology. Yes, okay. So
So we had been calling
sure.
them shallow and deep, but
Okay.
shallow, people didn't like shallow because shallow is still deeper than wide fast deep. And so that was confusing that shallow
Okay.
wasn't actually shallow.
Okay.
So yeah, so I think we're gonna go with deep for the what was before shallow and ultra deep for those one seasons for each field.
Thank you
Oh.
for I saw that fly by and I was like, I wasn't sure if that was a very specific version of the deep drilling survey or not. So thank you for setting that straight.
Okay, so the actual meat of the question was if we were to start the survey like in a month, Cosmos will be down. So the original plan of doing Cosmos in the first 1 to 3 years, of course, that can still be done, it'll just be shifted. Will another deep field be selected? And I'm thinking specifically of XMM because that one has gotten the least coverage so far.
Yeah. I mean, this is a great question, like how we should respond to dynamically seeing, oh, this deep drilling field is falling behind, so we need to change how we're going to observe it in the upcoming season. It's a really good question. We do not have plans to do that now. We're actually, it is an open question in my mind, what we do about the visits we've acquired to now when we tell the scheduler about here, start the survey. I mean, there's a very strong argument for we should just wipe the scheduler's memory of everything that's happened to date. We start over fresh at 0, and we do tell it where the templates already exist so that we don't try to acquire templates in regions where we already have templates. But and that's my pitch for how we configure the scheduling, the FBS's history of what we've done so far. But yeah, no, yeah, so Cosmos, you're right. We would start observing Cosmos with the deep season when it comes back up, and we do not want to add anything else into year one at this point.
And just to add, that wouldn't be that long. That would be November. So, if it starts in June, it would be just a few months. And I think part of the idea is also early on with the increased downtime, it's probably not the best time to do a lot of deep seasons, ultra deep seasons at the beginning. That was some of the thoughts that were going into that.
Keith?
Yeah, I was just going to make a quick comment about the clouds, which is that there are specific criteria that lead the Simone dome to be closed in order to, ensure the safety of the equipment. But other than that, as long as we can see enough stars that we can operate the active optic system in focus, we keep the dome open and observe. So,
Yeah.
so what that means is that in the simulation, there has to be some kind of like assumption of weather losses, but in practice, there's going to be a range of transparency for the observations, and the decision of exactly how that gets folded into building coads and so forth will come later during the data processing.
Yeah. So that's exactly why I mentioned, like, we don't apply cloud extinction. We just say open or closed. And then we just use the clouds so that our open or closed stays synced with about the right time of year. So we have more downtime in the appropriate times of year where it's more cloudy. But yeah, you're right. And as we go into operations, another thing we need to do is to look at how often we're closed due to weather and compare that to what we had in the simulations and to check that all of these things match up. Yes, Maria?
Thank you. Could we have also some additional information on the Euclid field south, please? In particular on the overlap with Euclid. Thank you.
Yeah, so the Euclid, so we do observe the Euclid deep field south. That's our EDFS field, and we don't have a lot of. We've tried to coordinate with Euclid, and they've tried to coordinate with us. I think at the moment what we have is the outcome of that coordination from probably a few years ago at this point. Mostly our coordination is in like making sure we're covering the same area that they have, and that's why we have two fields. And Saurabh has more to say about this, I think.
Yeah, so this is where, the deep drilling fields, maybe, the shallow season and the deep and ultra deep seasons becomes a little bit confusing. And this applies for the XMM question also. So I don't know if Lynn, if you could go back to the slide showing like I think it was XMM, the big increase. The, of course, there is that ultra deep season that happens sometime during the survey. But those other little blips that you see, they get, it's hard to see that, it's a lot of visits actually. So what's going to happen so even with EDFS South, even if it doesn't have its ultra deep season in year one, it might have it in year two. It will still get observed, and the way the deep seasons, or shallow as it was called before, are observed, it's still 2 or 3 visit depth with a nightly cadence, basically every other night in a given filter. So nightly cadence, alternating filters. And so, for example, you will hit the Euclid Viz 24.5 mag limit even in those quote unquote shallow, now we're calling them deep seasons. So it will be deep enough to do 24.5 in all the filters, maybe not quite in U or Y, but quite deep with basically every other night cadence. So for the people who are interested in deep drilling fields, there is this ultra deep component, and that looks like the most striking thing in this plot. But the other seasons will get very high cadence and to depth of 24 ish magnitude every other night. And it's in those ultra deep seasons that you'll get to like 27th magnitude, right? So that's a different regime that will happen, once for a given field during the survey. But the anytime EDFS South is visible, it will get observed with this every other night cadence to 24, 24.5 mag.
Yeah, I'll update the slide so that it says ultra deep and deep. Dan?
Sorry, me again, but this brought up another question. So, well, what's the strategy for switching between the two EDFS fields? And particularly, I think Roman has different types of observations planned for each of them. Is there any scope for coordination with them, or?
So let me talk about the EDFS, how it currently is observed. So currently we run these sort of in parallel, and so they happen at the same time over time. It's not we decided to go for breadth over depth. I think it was the answer essentially, rather than going one and then the other. Also, they do have. I don't know if it's like we'll talk more about all of the deep drilling fields tomorrow, but these are good questions, especially to know what's coming. So for the other fields, we dither in sort of a random offsets around the field. For EDFS A and B, because they're next to each other, we actually sort of dither towards each other so that it fills in the shape of the Euclid field a little bit better. As for Roman, we do actually have a field that is not a deep drilling field, but is a focus within the galactic plane wide fast deep area, which is like sending some of the galactic plane visits essentially and changing is wording it carefully. It takes some of the galactic plane visits and it focuses them on this Roman field that I'm so sorry, I'm blanking on the name of like what Roman calls it.
It's the galactic bulge time domain field.
Thank you. Yeah. So the galactic bulge time domain field. So we do try to coordinate how we're observing that field with a more intensive cadence during the time that they are observing. However, I believe that we are still looking for like when that coverage should actually be and an update on that. So we have something in the survey strategy. It will try to get more visits on the Roman field, but how those are sequenced and the time periods that's happening probably needs an update with like what's actually happening with Roman.
Yeah, if I can just add to that, the Euclid Deep Field South is also the southern Roman high latitude time domain survey field.
Okay, sorry.
So yeah. So that again, as I said, because that will be observed by Rubin anytime it can be observed, at least with the deep depth. So that's 2 or 3 visit depth every other night. But the one question that I think is still open is when should the ultra deep season happen for that field? And it's a question of do it early, like in year 2. That would be maybe when Euclid is observing it more, or do you do it maybe in year 3 or year 4 when Roman is actually observing it? And I think the timing of which season gets observed ultra deep for Cosmos, I think it's pretty much set that people want it to be year 1, year 2, year 3 for the 3 seasons. But for the other ones, they can still move around, and we don't have to make that decision right now. So input on that I think is totally welcome. Like, oh, it'd be good to time the ultra deep season for Rubin this year or this next year or whatever.
Yeah, I should mention, in case it wasn't clear, so I was the lead of the Deep Drilling Task Force, which is coordinating improvements to the deep drilling field strategy. So he's definitely who you should direct some of these specific comments or like here we think we have this new idea. So you can ask us, but also we're going to say it, ask Rob. So yes, and this is actually a really good point. We have these ultra deep seasons. They will, except for Cosmos, they will not be happening within year one, but the order of when that happens for the different fields after year one can certainly be adjusted. They do have to be like one per year. We can't do two fields with a ultra deep season in the same year, but we can adjust which year is which for the different fields. All right. If there are no more questions right now, it's actually time for our break. So this is great. Thank you all for coming to our workshop. Stick around after the break. We'll be back at 10, and we will have updates from the SCOC members on specific higher level science at that point. we'll start back in just a few minutes. As a reminder, the next session is the SCOC presentation of their science-specific metrics. All right, everybody. If the SCSU members are here and ready, let's get started. I know not everybody was able to make this time slot. So if there isn't somebody for a particular slide, if you can let me know when we get there. If one other member of the SCSU has noticed that, then please let me know and I can present those slides. All right, so I'm going to screen share, and if you guys can just speak to the slide when it gets to your slide, please.
All right, I think that's me.
Thank you.
Yes, so right, so in terms of sort of considering the different studies that we want to do with AGN in the AGN Science collaboration, these are some general thoughts that are mostly coming from me, as well as from some of the discussions with different members within the science collaboration. So in terms of the total number of quasars and AGNs that would be observed, we would expect that there would be a mild reduction in the baseline 5.3, mostly because of the lower depths. It's not going to be hugely impactful in terms of the total numbers, because at most redshifts we're already crossing L star, so we're already in the flat part of the luminosity function. But this is certainly something that it's going to get worse at towards higher redshifts, and this will have a bigger effect for very high redshift quasars. This, because it's all just stacked, should recover with the 11th year. However, it should be important to notice that a reduction in the area would actually be more impactful here, because then we would actually lose a lot more quasars.
Sorry, Roberto, can I interrupt just for a moment? Because I didn't talk about the extra year option.
Okay.
It's not really an option. So let me, I should introduce that. And I'm sorry.
Yes, okay, please.
I should have noticed from your side. So one of the simulations we did was, okay, we lost 10% of our visits. What would happen if we extended the survey for an extra year? Now, obviously, we can't count on that. It's a study, like what would happen. I believe also the intent is, if we need the extra year to reach our science goals, then of course we would argue to the agencies to support that extra year. But when we say an extra year, it's like in the simulation where we extended the survey for an extra year, this is the effect. Did it help or not? Sorry, go ahead.
Yes. Okay. No, perfect. Thank you very much for the clarification. Yes. So in this hypothetical 11th year would actually recover a lot of those numbers. In terms of variability studies, though, it's not that simple. And so the AGN studies require both cadence, but also the length of the light curves. And so the lower cadence would actually affect the lower luminosity objects a little bit more significantly than the higher luminosity ones. And it's unclear that adding sort of this hypothetical 11th year to the baseline would actually help the lower luminosity objects. However, for the higher luminosity ones, it might actually be might actually help just because of the slightly longer baseline. So thinking about the shorter templates, I don't think in general it should have a major effect, but it should actually slightly improve the cadence just because we're recovering a little bit more time for the regular WFD. And so that should definitely improve, although how much that remains to be seen. And then the last part we did consider would be the effects of if the DESI request is implemented. And so there's two ways to see it. So one is that U and G are really important for quasar identification. So actually going deeper first would allow us to actually go and do a better job identifying quasars in there and prepare better for the rest of the survey. However, it is very detrimental for the variability of quasars. Again, what we need really there is the length of the light curve, not as much the cadence, because these things don't vary that quickly. And so having no U and G band after year 3 would actually preclude most variability studies in quasars in those regions.
Sorry, let me also say here. Sorry, I should have introduced all of these simulations a little bit more earlier. I had left it for tomorrow to talk about more of these in detail. So I'll give a little brief overview about this. I did talk about the shorter templates. So this is just what if we did the templates with shorter exposures. The DESI strategy I didn't talk a lot about. The idea here is, as I did say earlier, is that we cover this an area in the northern part of the footprint to accelerate the observations in this part of the footprint into earlier years. And the biggest impact is in U and G. So the side effect of accelerating the U and G and all of the bands in this part of the sky is that because you accelerated them into years 1 through 4, then later you have fewer observations in this area. And the way that the scheduler works, how we implemented it in these simulations, is that we get these observations early. And then because those parts of the footprint look like they're ahead, remember we're doing ratios to keep our visits distributed as we wanted. So then these parts of the sky look like they're ahead, and then so they get very few visits until near the end of the survey. So it's not that they don't get any visits, it's that they get practically none for several years. Now, we also have updated these simulations, and so we're looking at options to make it like a little bit less drastic, but it is true that by accelerating U and G into the early years of the survey, then we are at a lower cadence for those bands after we reach the DESI goal footprint. And it could mean quite depending on the details in the updated simulations, it could indeed mean a few years where we don't really get any U and G visits in that part of the sky for a little while. Again, these are things we can look at and we can tweak, but in the versions that we have, this is kind of how it looks.
And it's worth mentioning, I think you didn't mention the area, right? It's 5,000 square degrees?
Yes, sorry, I did not mention the area. You're right. It's 5,000 square degrees.
That's all I had to say.
Okay. Question?
Yeah, this is just Neil Brandt. So we did discuss this issue yesterday on the AGN Science Collaboration Telecon, and I would say that in general, nobody really liked it, and many people just felt it was a non-starter, losing all that variability information for the AGNs. So we will continue to do analyses, but at least that's the initial reaction from the AGN Science Collaboration. And may I ask, this DESI strategy has not been agreed to, right? Just for
No.
purposes of clarity, this is a possibility. It's tentative, but if we push back, it might go away. Correct?
Yeah, and we will talk more about this tomorrow. So we have a discussion period and questions for that about this in more detail tomorrow. But yes, it is not in the baseline strategy that we would go on Sky with, like within this month. Yes, Bindi?
Hi, Lynn. This is Bindu. So, there is one thing I like to understand over the course of time. How flexible are we, in changing our strategies or like evolving according to the needs of the different science collaborations?
So this is a really good question for like that brings in the SCOC procedures and how the SCOC works. And in general, we could be quite flexible. This is still how you have to change, any changes in the survey strategy would go through the SCOC's recommendation process. And so that would be like I'm actually not quite sure how to answer this because yes, in theory, we're very flexible. If, for example, the scientific landscape changed and said, you know what, actually cosmology is solved, so we don't need to do cosmology anymore, we would probably pivot to doing a lot of time domain stuff, right? So it is very flexible. However, assuming that cosmology is not solved tomorrow, there are still goals that we have to meet for cosmology. So in that respect, it's also not necessarily so flexible. So it's a hard question to answer. Yes, it's flexible. We also still have goals that we're trying to meet that may make it less flexible because we don't have huge amounts of excess time to be able to change our strategy with no cost.
Thank you.
I don't know if that answers your question or what you were looking
No,
for.
I work with Swift, and let me put it this way. And so when it was launched back in 2004, it was mainly a GRB mission, and now other than GRBs, there are like 20 other different kind of like objects it's discovering and detecting. So I think it's important in that way to. So my question was more in the sense like, let's say if there is a particular need for a particular kind of science case, then, the procedure, how long does it take to get it through the whole process of getting it approved, if it gets approved?
I think the big problem, I think the big time constraint is making sure that we get simulations created, simulations and evaluations of the impact to the SCOC, and then the SCOC will need to deliberate on that and also talk to the community. In practice, a major change in the survey strategy, I think, would take probably at least several months.
Okay, thanks.
A more minor change, I would imagine, could be done more quickly. As an example, when we changed the footprint, and given that this was much earlier before the start of the survey, it would probably happen quicker now. But when we changed the footprint, it did take on the order of a year to look at all the different options, look at how we would make that fairly big change. And then we had the SCOC recommendations and we changed it. When we are adding this template tier now, this is on the matter of a few months. Maybe technically speaking, it's less than a few months. It's maybe 2 months that we've talked about this with the SCOC and said, okay, this is what it looks like we need to do. We did have earlier simulations that they saw with different versions of the template tier, so there was also some iteration on that. So, perhaps a few more months than that. A major survey strategy change, yeah, it's hard to say. Obviously, it would depend on the impact and the benefits. All right. Great questions. Roberto, I think you had gotten to the bottom of this slide.
Yeah,
So
I'm done.
I'll go on to the next. Thank you.
Okay, I think this is me. So, Sarab, one of the members of the SCOC and one of the liaisons with Desk, along with Rachel Mandelbaum, who the two of us put these slides together, and also Stephen Smart, who's another Desk liaison on the SCOC. Okay, so our initial impressions of the V5.3. The changes that we're seeing in the metrics make sense. We have 10% fewer visits, and we're seeing 5 to 10% decreases in cosmology metrics that are of interest to Desk. There are a few things that have a bigger increase, and so that's supernova cosmology, and these are both time domain, and then also using kilonovae for cosmology. And so there we see the metrics change by something closer to 15%. And so we're trying to understand why that is. It's presumably because of the worse cadence. You have fewer visits spread over the same amount of time, so you have worse cadence. So further analysis of that is underway, both on the static side. Michelle Lochner has done some stuff, and then Philippe Gris is looking at the time domain metrics. And so we should hear back sometime soon from them. Another issue the desk raised is that the uniformity metrics, there are some in math, but they were not run on these simulations. And so we do need to investigate that a bit more. Even the ones that we already do have, those are focused on RIZ, looking at the uniformity in RIZ for what we call the 3x2 point cosmology metrics. We want uniform data releases so that the depth does not vary, especially on cosmological angular scales across the sky, and lead to a major systematic in the cosmology. So those uniformity metrics. There are a lot of changes, especially early on. And for example, in the DESI sim where the U and G are accelerated, the U and G didn't really go into those metrics because we just assumed that all the filters kind of ramped up in the same way, and that, for example, photo Z's would be available, improvingly available over time. And so there may be some subtle things that need to be looked at more in terms of if those observations gets moved around. We do worry that a lot of the metrics were run only on year 10, and Desk would like to do cosmology analyses earlier than that, in year 1, and then either year 4 or somewhere in there. And so the impacts on the cosmology at those epochs, especially with extended downtime early on, could be more significant. So that's something we still need to look into. This is something that we share with the Galaxies science collaboration, which we'll see later, that if the TOO observations, which though they're only about 3% of the sky, they do introduce some patchiness in the number of visits and perhaps in the total depth, though maybe that effect is less. And if they're included in the coads in the data releases, there's a concern that, we want uniformity for cosmology. Galaxies wants uniformity for their catalogs. So patchiness in the sky at, again, relevant angular scales for cosmology are an issue. And so we're a little bit concerned about the effects of that. This idea of building catalogs and coads that are more uniform, this is something that, it's like, you can choose to not include all the data to become more uniform. So there's a trade-off, and then there's a DM cost there. And so, we think that this still has to be an open issue that needs to further investigation. And then, Lynn, you already mentioned this before, but rolling only makes sense if there are already templates. Rolling affects uniformity, and so we would want to ensure that the rolling starts only in regions where the templates already exist. And so that may change exactly the start of rolling. That's something that we would want to look at later. Yeah, I think that's all for this slide. And we had some suggestions for some more simulations and some more work on the next slide. Okay, so one thing is, with the 10% fewer visits, going to the 11th year, for example, recovers the depth and is probably okay for static science, but you never really recover the cadence. So for time domain, even if you did an 11th year, you would get new transient objects, let's say new supernovae, for example, but you would never recover the cadence on the supernovae that you had in years 1 through 10. So the idea of, if that becomes, very significant, that this reduction in cadence is more than just the 10%, then something that Deska suggested is looking at a reduced wide, fast, deep footprint. And so maybe reducing the footprint by 5% or even 10% to see if we can get that cadence back and how that would interact with everyone else's science, of course. One idea was there is part of for DESC anyway, the extragalactic low extinction, wide, fast, deep region. There are still some places where the extinction is kind of too high for DESC. And maybe those regions are also kind of too low stellar density to be interesting for the Milky Way folks. And so maybe there is some 5%-ish region of the footprint that could be shaved and that wouldn't really impact anyone's science too much. And so then we could recover the cadence, get more visits back onto a smaller footprint. So something we were just, suggesting to be at least simulated and look at what footprints that might look like. And then, of course, we wanted to run the uniformity metrics and science metrics on the early years to explore those impacts, as I mentioned before. And so, for example, Matt Becker has been looking at this uniform rolling strategy about trying to time up the rolling so that you get back to uniform data releases at certain checkpoints. Maybe the right thing is to change what checkpoints those are. It could be year 1, 4, 7, 10, or maybe years 1, 2, 5, 10 would be another way you could move the rolling around and accommodate, starting rolling after year 2, then you would naturally have relatively uniform in year 2. So there's some ideas like that we would like to continue working on. Okay, and that's all I had.
Let me unmute. So thank you, Sarah. Are there any quick questions here? We will have time for questions at the end, but we can also take a few as we go along if they're more directed. Okay, let's go. Okay, so galaxies, I don't think Louisa is here, so I'm going to talk about this, which was primarily that the issue about deep coads and homogeneity, uniformity in the coad is important and is a priority. So the issue that we're seeing here is that when we just make a map of all of the visits, including the TOOs, especially at early years, and especially if you look in some of the bluer band passes, you do see the signature of our simulated TOs. Now, obviously, these are simulated TOs. They're not the real TOs. The real ones would look different on the sky. So these are just standing in as an example of we would have non-uniformity coming from just the fact that we observe TOs, which we want to do. So we have to grapple with this question: how do we make catalogs that are useful for the science collaborations? And if it's that they have to be uniform, how uniform do they have to be? How do we work with data management in order to be able to make a suitable catalog? So Leanne is going to talk a little bit more about some of the options for this tomorrow. And we'll talk more about uniformity at that point. This also comes in from rolling cadence. It's just that with rolling cadence, that's why we have these uniform seasons, so that we can have some of the data releases that were a bit more uniform. And then also, if we were to follow the DESI option, then that also affects uniformity in the early years. So the next part of this, the other comments on the slide, yes, as patchiness, the number of galaxies has gone down in v5.3.0. I think this is, we didn't change the footprint. However, because we have slightly fewer visits. And because things are always a little bit different in their uniformity, you can, if you make a sharp cutoff for the number of visits you're looking for, you will always have some parts of the sky which fall just below that, and then others that are above. And so if your threshold stays the same while the overall number of visits per pointing falls, you're going to look like you have less area. The number of galaxies metric, however, just counts up the total number of galaxies with a input luminosity function. So it shouldn't be falling victim to that necessarily. So I think this is actually the fact that the depth has decreased slightly. And again, it's band dependent. RIZY would be the bands where we look like we're losing depth. So yes, in this case, if you added an 11th year, you would regain that depth. And so that would be helpful. I think I have covered the points here. All right, so let's go to the next slide. Do we have somebody from the ISSC to talk to this? Maybe not. Okay, so the ISSC is the information science. That's probably not the right acronym, but if you want help with doing statistics work, doing other more complicated analysis, the ISSC collaboration specifically wants to be involved in projects like this and offering to be a resource. So these questions here, what about a hackathon? I think this is aimed at like, what about metrics? Well, I would love it if it's aimed at metrics hackathon. It may also be like looking at, well, how can we analyze data that's already coming out of DP1 and so on. And then they had a comment about the links software is now mature and could be useful here. I believe this is the light curve links software, which was developed in collaboration with the link. I forget what that acronym is for, but it's a group out of Dirac at University of Washington. And so this is a new software package for simulating light curves. So I think it would be great if we can get some points of contact for the ISSC, and we can make sure that we publicize those and spread those around. Okay, next is the strong lensing science collaboration.
Yeah.
Okay, thank you.
Great. So, hi everyone. So this is just a couple of thoughts that we had on these new metrics and new experiments. We do have one metric in the system that is a time delay metric, basically measuring time delays between multiple images of lens systems. It is quite outdated, so I don't think it would actually measure a lot of the things that we believe would happen. So with the new baseline, this would influence naturally all the trends. Well, one thing that you need to get in mind is that strong lenses are rare. So basically, what we want for strong lensing is as wide a survey as possible and as uniform as possible, the cadence. Okay. So with this in mind, we have some thoughts. The new baseline, well, 10% less visit will influence, of course, many of the transient metrics. This could be so. Some of the science that we're doing, for example, quasar microlensing, these are very long timescale events. Okay, so this experiment, thinking of an experiment of an 11th year, would probably make it even better than having 2 years at the before cadence. Again, with time delays, this needs to be further tested. The experiment with the faster templates seems to reduce the internight gap. This would mean that it's even less uniform than the normal baseline. So this would definitely not be good for at least quasar microlensing. And again, time delays need to be explored a bit deeper. With regards to the DESI simulations that Lynn was mentioning, these smaller 4,000 square degrees, this is, of course, definitely not good for quasar microlensing because the events are very long and there are more evident in the U and T bands. Okay, so if we remove uniformity and even more from the U and G band, this would definitely not be good. Time delays might improve. This is something that we need to test. And the fact that they might improve is that the nominal cadence for U and G tends to be a little bit too not high enough to actually be useful to measure time delays. So maybe in that particular area, having a slightly faster cadence, even if it is a couple of years, could help. But then again, these are just thoughts and it could be tested. And we have some metrics that are just not run automatically in the system because they're a bit more complicated, that we will be able to test this. However, this would also remove uniformity in the rudder bands, which are useful. So again, it could work both ways. Having a higher depth in G-band earlier in these areas could actually be better to find our lens systems that we're going to monitor and then follow up for lens transients. Whatever, if something like this DESI area observations occur, again, as always for strong lensing, the more uniform, probably the better. So these are the thoughts that we had, and we had it with a small reduced group, and we're open to other people that might please give us some thoughts. And that's all I have. You're muted, Lynn.
Thank you. I thought I unmuted first, but not successfully. Okay, thank you. Next up, sorry, any? Okay,
That
good.
would
So
be
we'll
me.
go. Yeah, okay,
Unless
great.
there is questions for Timo, I don't know. Okay, maybe let me go ahead. So this is me. I am Katy Vivas, Noir Lab La Serena, Chile. I am the liaison with the STARS Milky Way and Local Volume Group. So these are like first thoughts about the new simulations, but this is still to be discussed more deeply with the science collaboration and well, there are things that we need to explore. But in general, of course, we see a reduction in the metrics that affect this specific science collaboration. But in general, they do good, and there is no metric that is particularly affected with the new simulations. One thing that, well, we're happy that the area coverage, especially in the plane, is unaffected, so we're still getting observations there. So that's one thing to say. So I am showing some plots on some of the metrics things that are slightly more affected than others, and that's you can see here the population of brown dwarfs. Those are slightly like more affected than other metrics, and also we see more than 5% decrease in the recovery of ultra-faint dwarfs galaxies in the SCP area. So these things have to be explored. As others have said, for other science collaborations, most of the metrics recover fully with an 11-year of observations, but as Lynn had said before, we shouldn't count on that because this is just an experiment and not something that we have. But it's good to have it into account. So with respect to the specific variations in the baseline 5.3, so it seems that particularly for these two that I'm showing, the brown dwarf population and the ultra-faint dwarfs, the variations that have changes in the DDF and the short template seem to have the larger effect. So again, something that we can explore more deeply with the science collaboration. I should mention also that the RR-LiDAR metric, which I am not showing here, but is in the GitHub with all the metrics, is also slightly affected by the short templates variation of the simulation. In the short templates, in general, we see a decrease in the median single image depth in U and G, and that's probably the reason why we see a slightly drop in the efficiency of the recovery of our LiDAR stars. Regarding the DESI variation, we probably do not have metrics that can assess the impact. So my initial thought thinking, particularly in the Ara stars, the increased number of epochs early in UNG actually may work okay for may work better for the early recovery of the Ara star population, but it can have a detriment on studies of long-term variability on this and other kind of variable stars that can help us with the structure of the Milky Way. But as I say, we do not have metrics about that, and that's something that we should study with more detail. The other thing that I think we have to look at is we need to have a closer look at metrics that evaluate early signs. Those may be more affected, but yeah, we don't have results now for that. I think young geese have been working on evaluating the metrics for parallaxes with this new simulation. So hopefully he can talk on Monday and show his results. And I think that's all I have.
Thank you, Kathy. And now we're up to the Solar System Science Collaboration.
All right, I'm Kat Volk. I am the SCOC liaison for the solar system. And, overall, the kind of top priority when the solar system collaboration has been looking at metrics from the simulations is always total discoveries across a variety of solar system populations. And that is fairly unaffected by the changes in the downtime and the reduced number of visits, just because detection only requires a set number of visits. So that's the good news. The detection numbers are looking pretty good, although we are still interested in looking at what those look like in the early part of the survey, not just the 10-year part, also to figure out, funding proposals and planning observational follow-up with other facilities. Some of the metrics that do take a hit from the reduced number of visits are the characterization of the detected objects, kind of as expected. So the light curves are the most strongly affected. So that is the bottom panel here, this figure. So, a bunch of the populations are taking kind of a 10 to 20% hit on those. A couple are taking larger hits. I did mean to follow up with Lynn asking about the Jupiter Trojans and why those take such a big nosedive, but it's been a weird population in the metrics. So I'm sure we can figure out why that's happening. The other thing we're interested in are the colors of the objects. Those do take a hit, but it is more at kind of comparable 10 to 15%. So about on par with the lost number of visits. So, we would like more of those, but I think we understand that that's just the loss in the visits. If we were to add that 11th year, we do recover a lot of these things. So, the light curves is kind of it's a time domain, obviously, but they're not short duration. We're just interested in looking at these objects as they rotate. So sparse light curves are fine. It does not have to be over a short period of time. So our light curve metrics do recover for the most part with that added year. For the DESI simulations, I think we would need to look at those in a little more detail. I don't think the effects of that are going to be fully captured in the metrics we have provided, because even though I said the light curves and things do recover with just more time, there are some transient events like asteroids that are normally not active that outburst. And those are types of things we would like to be able to see in the data that do rely on a specific time cadence of the observations. Other things like comets coming through the solar system that might not be available for the full 10 years. So there's some more stuff to look at there. But I think that was pretty much it for my first impressions from solar system.
Thanks, Kat. I'm actually going to make a quick hypothesis about the Trojans, because the thing is, any metric which has a threshold, and this doesn't just apply to solar system metrics, it applies to all of the many of their metrics that we have. if there's a threshold that you can drop below, and dropping below the threshold drastically changes your metric result, then your metric is more sensitive to changes when you're getting close to that threshold. And I think that's probably what's happening with the light curve inversion metric. It requires on the order of 100 visits. I think depending on the signal to noise, but it's either a fewer number of very high signal to noise visits or a larger number of lower signal to noise visits, and it's quite a few. And that's a threshold. And probably we were very close to that threshold for a large number of objects before, and now we've fallen below that threshold for a significant fraction of the objects. And it may be only the difference of, 5 observations for those objects, but it's enough to throw them below the threshold for the metric. And then that means that we did not succeed for those. Which,
Yeah.
It's hard to capture. This is real when you're trying to do analysis. Thresholds are always real like that, but also they're not usually quite as cut and dry.
Yeah. And I know that in the past, as we've made cadence, that particular metric, the Jupiter Trojan light curves, has taken nosedives like this in the past. So I would not be surprised if you're correct that that's just a population that is hovering near whatever threshold we set for that metric.
Yeah, and this is true, and I don't mean to single out the solar system. It's just like you've given me this perfect example of like what happens when you have thresholds in the metrics. Which
yeah, it's a reminder the metrics aren't perfect.
Reasonable. Yeah. Yeah, it's another reminder. And it's completely reasonable. This is exactly how science works. It's just if you were doing this science yourself in real time, you would probably look at that and say, okay, how can I get around this? And we can't do that with the metrics. This is our last slide. I just wanted to make a little quick comment on some of the overviews. I do see we definitely are lacking metrics evaluating early science, essentially, which makes sense because a lot of the survey strategy we've been evaluating to date is the overall survey strategy for 10 years. And now we're in a very different mindset and different place. And so now we're like, hey, we need to know what's likely to happen over the next year or two. And as Kat pointed out, is very important for funding requests and planning follow-up, real things that are tied to how the survey will progress. And so I do agree we need to have a look at that and rethink how we're running some of these metrics. Maybe not all of them can just be run as is on shorter timescales, but certainly we can look at what happens in the first few years in more detail. So we do hear everybody on that. And also, I think like the fact that there's these things that aren't captured by the metrics because they're very unusual survey strategies, it maybe speaks to a little bit of lack of imagination on our part for making simulations that were very unusual. And then again, we don't want to waste anybody's time with simulations that are completely not in line with what we would expect. It's just our expectations actually include a wider range than we had perhaps anticipated. So I think now we can open up for questions and on the things we have so far, and we'll see. We can also talk about what we might talk about tomorrow, but there will be some we can delay till then. Rachel.
Hi, Lynn. I was just wondering if you covered the TVS slide, or is this in alphabetical order?
Oh, I'm so sorry. How did I miss that? Oh, you know what? I think that I thought I had clicked to the last slide, but I had not. My apologies, Rachel. I did not. Do you want to talk about the TVS slide?
No worries. So hello everybody, I'm Rachel Street. I'm the SCOC liaison for TVS, obviously. And just to summarize my impressions of the new OpSims. Firstly, I wanted to highlight that the median pair filter time gaps metric initially looked like it had some quite alarming dramatic drop, but I'm assured by Lynn that in fact that this metric was not updated, and in fact, the result is not as bad as that. So having said that, we've heard that light curve coverage is diminished by the latest OpSims, and that does have an effect on most of the transient and the variable star science. In particular, we see decreases in the numbers of supernovae detected, and we see decreases in the kilonova population metrics. They decrease by about over 10%, but the color measurement metrics were less affected. We see some degradation in the AGN time lag we see some small improvement in the time lag metrics for AGN, but we see degradation in the area threshold, so kind of a mixed results for the AGNs. The microlensing metrics were badly impacted by the FAST template and the DESI simulations. Although I did want to note that that metric only considers data in one filter, so that could be sensitive to the filter balance. The key takeaway for a lot of the time domain science cases was that the detection metrics were okay, but the ability to characterize those discoveries was reduced by the reduced coverage. And in particular, the median internight gap was reduced by the FAST templates and the DESI simulations. And that has some benefits for some of the short-term variability, but overall it degrades the longer-term cadence and the monitoring of the longer time scale phenomena. And those are key areas that are of interest to TVS members. However, most of these metrics do recover if you add another year to the survey, which improves again the coverage. So that was our summary. Thanks, Lynn.
Sorry again, Rachel. Thank you. Yes, and I apologize. We realized that this metric about the filter pair T-gaps was being run incorrectly, but we did not manage to get it corrected in time for this presentation. It does drop, as you said, it just doesn't drop to 0. So I'm guessing it will drop on the order, same order as the kilonova and so on. So about 15%. All right, and now we can have questions. Okay, or no questions. It's fine. I love that you guys must have socialized this with your collaborations so well that we know everything that we've talked about, and we don't need to talk about this more. Okay, well, in that case, what I'm going to do is flip back to the agenda for tomorrow, and just make sure that and just review what we're going to talk about tomorrow, if my computer will listen to me. Okay, well, I'm guessing I won't. Gosh, it really won't flip to the other screen. Okay, so tomorrow we have some more focused sessions. We're going to talk about the DESI simulation. Obviously, we're going to talk about the fast templates option. We're going to talk about rolling cadence and just some ideas about delaying it. And we're also going to talk about like what things we know about in the current simulation where we still have, these are things that we don't necessarily know, or we have something in the simulation we already know, it's sort of a placeholder. So, mostly that's related to the downtime, for example. And I think that covered it. We'll talk about what we need to know when we're going on Sky and what we can add in later. So basically laying out some of the questions the SCOC will be looking at various timescales over the next year, I think. So, all right. And we can be done early. Enjoy your extra 40 minutes. So we'll see you all again tomorrow, bright and early.
Thank you, Lynn, for great slides. Great meeting.
Thanks, Shilpa.
Thank you. Bye.
Hey, David, thank you for hosting the meeting on the Noir Lab Zoom. You can turn off the recording now if you are online to do so.